Data delivery in communication network is of two types: the guaranteed delivery and best effort delivery. The guaranteed delivery, also called reliable delivery, ensures an acknowledgement to the sender after every packet is delivered to the destination. If due to some reason the data is not delivered, the intended receiver informs the source to retransmit the data packet. On the other hand, the best effort delivery, also known as unreliable delivery, tries the level best to deliver the data to the destination but does not promise any guarantee. If due to some reason the data is not delivered to the destination, the source is not informed about the failure. In absence of transport layer, the data communication network would have capable of only best effort services. Due to presence of transport layer, it is possible to provide reliable or guaranteed service to end users. And the guaranteed service is offered by the network, or for the guaranteed service provisioning, the transport layer performs the following three tasks. One is the flow control, error control, and congestion control. The flow control, it is the process of controlling the speed at which the data is transmitted to the receiver. It ensures synchronization between production and consumption. For example, suppose that this is a source and this is a destination. The source will send the data to the destination, and that data will be used by the destination or the receiver. And if it is like the way the S produces packets, suppose that S produces 5 packets per second, but R can consume only 2 packets per second. In that case, every time the receiver R will not be able to complete the consumption of using of the data packet which been received from S. So as a consequence, the packet will be lost here. So it informs, the receiver informs the source to slow down the data transfer. So this is called flow control. Error control, when the packet transmitted from the source to destination, due to some reason, suppose that D1 is the packet data which has been communicated to the destination, and while receiving D, it receives D1 dash instead of D1. That means it has come to the notice of the receiver that D1 contains some error. Or it may also happen that D1 during the process of transmission, it is lost somewhere. That means D1 is not received by the destination. These are some kinds of errors which is being taken care of by the transport layer. And that procedure where this type of errors are taken care of is known as error control mechanism of the transport layer. And the congestion control during the transmission, when we transmit packet through the network, it goes via several intermediate devices, R1, R2, this is source, this is destination. Now, it is very obvious that many devices will be connected to the same network and all of them will transmit data. And these transmission links have some limit of sending data, which is called the bandwidth. If it happens that due to the generation of packet by multiple sources, this network link is not capable of sending all data, it is incapable of sending data due to exhausting of the bandwidth. In that case, packet will loss. So packet loss occurs. So to control the packet loss, the network or this destination will inform the source that the packets are lost and it is not being received by the destination. So there is a congestion in the network. Then you slow down the transmission of data. It will instruct the source, the destination will instruct the source to slow down data transmission, and this is called the congestion control. In fact, in a computer network or in data transmission network, congestion control is taken by the destination as well as intermediate routers. All of the nodes or elements in the network play some role in order to control the congestion. There are several methods for handling these functions in the transport layer. For example, in flow control, mainly used protocols or methods are stop and wait, go back and selective repeat. For error control, it make use of forward error control mechanism or error control mechanism by retransmission. And moreover, for detection of errors, checksum, the concept of checksum is used by the transport layer protocols. Similarly, for congestion controls, there are many methods and which is being taken care of by the transport layer in up to great extent. And it includes the window policy, where the concept of congestion window is used. Retransmission policy, when packet is lost then it is retransmitted. Choke packets taken care of by the routers. Back pressure also taken care of by the routers. In the network architecture, error and flow control is performed in two different layers. One is in data link layer and another is in transport layer. And why does it done in two different layers? It is a very critical question to be answered. Let us discuss both error and flow control from the above questions perspective. If I say error in data communication, what do we understand? It implies that loss of packet, unordered delivery of packets, or it may be the error because of bit corruption. And during the process of transmission, any of these three things can happen. And the loss of packet and bit error because of the bit corruption, these two errors are taken care of by the data link layer. And the unordered delivery of the data packets, which is also considered as an error, is taken care of by the transport layer. Then a question may come to our mind, why this unordered delivery of data packets or data is not taken care of by the data link layer? Because unordered delivery is detected only by the end system. That means the process which consumes the data. the data link layer have no way to know whether the packets are arrived in order or not ordered. So that is why this error cannot be handled by the data link layer, and this is handed over to the transport layer. Next is flow control. There are three main regions of controlling the flow. The first one, the intermediate routers are not capable of handling the data. Second one, the network is not capable of handling data. And third one is the end systems or the destination. Destination is not capable of handling the error. If data cannot be handled by routers, it means that when data is passing from one router to another, router R1 to R2, if this router R2 cannot handle data, then it will inform the previous router to stop the flow or slow down the flow. But however, if the network cannot handle the data, that means in the entire network, there is a link failure or there is a congestion in the network because of which the network cannot handle the data. So in that case, somehow this network need to inform the source to stop transmission or to slow down the transmission. And third one, suppose this is destination, this is the source, or this is the receiver and this is the sender, and the sender is not capable of consuming the data at the rate which is being received from the sender. It implies that the sender and receiver speed is not synchronized. In these two cases, when network is not capable of handling the data packets or the rate of data packet flow, and the end system is not capable of handling the data flow, then these two operations, these two cases cannot be handled by the data link layer, because the data link layer works locally. It can tell what is happening to its neighbors. If this is the network and these are the routers, then this router can tell what is happening here or what is happening here. That is called the router. In the data link layer, they handles the activities locally in the network, whereas these two activities are not local activities, rather these are global activities. That is why the data link layer fails, or the flow control of data link layer fails to handle these two issues which requires the flow control. So flow control is extended to the transport layer, for better end user provisioning or end user experience.